Hello everybody and welcome to this episode of G-Bear's Off-Grid Ways, a homestead in the desert, as it said in the beginning. So, I'm here and a dust devil just blew by outside, but let's get to this. We're going to do a review today on the WattCycle 12 volt 100 amp hour battery. And I've got everything set up here as to the way I'm going to do the video. Now, you're going to wonder why are you saying the way you're going to do it? Simply because there are thousands of battery review videos out there, and everybody does the same thing. They do a capacity test. Will it actually give you 100 amp hours? Well, if it doesn't, that'd be pretty much false advertising. So let's give the companies that make these things a little bit of credit for being a little bit honest, because hey, let's just face reality here. The market on LiFePo4 batteries right now is completely diluted. There is billions of them. Well, maybe not billions, but there's thousands of companies out there selling LiFePo4 batteries. And yes, you might find a couple of them in there that are trying to cheat you and not giving you what you're supposed to get. In the meantime, I want to figure that they're getting pretty close to that. So, you see all these other guys doing videos, and on the videos, they have all this special apparatus and gauges and stuff like that all set up. And you say, well, you do too. No, this is just minor stuff. This is not all the meters and gauges and capacity testers and load testers and all that stuff that they have. And why am I not using that? Well, because I want to do a reality check. This is going to be reality. This is going to be what you, the layman, the consumer out there, wants to know. So what we're going to try to do here is, I have, let me see if I can tilt this down. I have this freezer here. And this freezer, it was another video that I did a while back, but this freezer is going to be our test subject. And the WattCycle 12 volt 100 amp hour battery is going to be our supplier. And I have an old Harbor Freight inverter here. Now, this is not a pure sine wave inverter. This is a modified sine wave inverter, and this is a pretty old one. I gotta say, it's probably 20 years old, because I've got two of these and they're still working just fine. And I'm going to attempt to use this for this video. And I don't recommend that you use a modified sine wave inverter for anything more than maybe running power tools. But we're going to do this video because what I'm going to attempt to do is run that freezer for as long as it will on that battery and see how long that battery will actually run this freezer. Okay, now this is not a mini fridge freezer. This is just a freezer. And I'll be showing you that in a second when I open it up and show you the insides. It is just a front load freezer. And I love that little freezer, but that's another story. Alright, here I have a kilowatt meter. And that's going to keep track of the watts that's being used by the freezer. Alright. And up there on top of the battery, I have my little solar battery charger, and right now that solar battery charger is being charged on my power supply, so that we start off with a absolutely fully charged spec of the thing battery without any usage at all off of it before we start this video. So you're going to get the true usage out of this battery. How long will it actually go on one 12 volt battery? Now let me specify one other thing. on LiFePo4 batteries. They may put 12 volt on there. That's because of the room they had. But actually, these are all 12.8 volt, 100 amp hour. Okay, so I should get 1280 watt hours out of that battery, which means I should be able to run 1280 watts for 1 hour. Now this freezer is not going to be anywhere near that. I think this thing is way down there in the 60 or 70 watt range, so it should be fine. Now, to keep track of it, I will be able to read the watts on here, the kilowatt hours that were used. I can read the amps draw on here, and I can read the voltage on here. All right, now up there on the charger, I'm going to be disconnecting those wires you see running down in front here, the red and the black one right there. Those are going to, right now, they're going to this power supply, charging that battery up to full. Because I want to start with being honest, with a full battery so that I don't cheat the battery company and start with a half-dead battery. I want you to see that that battery is fully charged when I get started. Now up here, I have my laptop sitting there, and I have a stopwatch on the laptop. And I'm gonna, when I start this thing up, I'm gonna start the stopwatch, and we'll see how many hours and minutes we get out of it. Now remember one thing here, this is not in any way going to cheat for one side or the other. I want to do this completely honest for you viewers out there, for my viewers out there. But from what I've seen and what I've researched, WattCycle is a good, reputable company, and they make a good LiFePo4 battery. Okay, so that's my opinion on them, and we're going to go from there. Now, here's the surprise. After we do the freezer test on this, we're going to really load it down. I got a 5,000 BTU window air conditioner right behind there. So after this freezer video is done, and we get the specs on it, I will recharge the battery back to 100%. And we'll start the whole thing over again, but this time, instead of plugging in the freezer, we're going to plug in the air conditioner and turn it on. And we're going to see what we get out of performance for that air conditioner. Now, isn't that the kind of stuff you guys out there want to know? Come on, show me some hands out there. I'm sure that's what you want to know. You don't want to know what's inside that thing. There's nothing in there you'd be able to fix anyway, right? And then most of the people, they could tear that thing open and look inside, and they're going to go, what in the heck is this? What in the heck is this? They're not going to know. So that information is for the tech guys. That's not for you guys that are out there that are the consumers who want to use this battery for one thing or another. All right? So, all of that being said, a little long-winded, but I had to get all that information out. Let's get to the testing here. So I'm going to grab this unit and come forward here because I want to show you something. This is another little inverter I got from Harbor Freight years and years ago. This is only 800 watt inverter. Okay, and this is also modified sine wave. Now this one had gone bad, but I repaired it back on September 25th of 2020. So this one is in working condition. It's been tested and all of that, but 400 to 800 watts is not enough for this type of testing, especially in modified sine wave. The surge of a freezer starting up will probably send that thing into whining mode, where it just sounds off the alarm and says, I can't do this, I can't do this, I'm not the little engine that could. All right, so also I'm going to, right here in a few seconds, I'm going to shut off the charger because I know that this is at full charge. I can see the light flashing there. We're at full charge. I'm charging right now at 14.5 volts at 5.8 amps. And that's just to top this off because this battery was already fully charged prior to all of this. And you saw that in my giveaway video. And by the way, I'll leave a link to that in the description. Go back to that giveaway video if you're interested in winning one of these free of charge on my channel. We're going to be having a drawing because the giveaway ends on the 22nd. So right shortly after that, I'll be announcing the drawing date, and it'll be a live video drawing with a spin the wheel on my laptop. Everybody's name that enters will be on there. The instructions on how to enter are in that video, so click the link down in the description below and go check that out and get signed up so that you're on that giveaway. It's a nice battery, and it's a nice thing to have. Now, they're giving away 4 different batteries. I'm not sure if I get to give away all 4. I just sent an email to the company rep to see what they say. If I am allowed to give away all 4, we'll have 4 drawings. We'll have 4th, 3rd, 2nd, and 1st place drawings. All right. If I'm only allowed to give away 1 battery, then we're just going to have a single drawing for a single battery. All right. So I'll let you know what they say on that in a near future video. So click the subscribe button below. Make sure you subscribe to my channel. That's part of the deal. You have to be a subscriber. It doesn't cost you anything. Free to subscribe. If you do want to donate some money to help me keep going and keep doing videos like this, you can also join a membership. And there's 5 levels of membership that you're allowed to join. Choose your level and get in there, because there's membership perks that you get that non-members won't be getting. All right? So let's get on with this thing. Ready? I'm going to set this down over here. Let's see where we're going to start here. First of all, I'm going to shut off the charger. And I'll move this over for a second. And we're going to unplug the SAE connector going into the charger, so there's no funny business shenanigans going on there. Then we're going to tilt the battery charger up. Oops. I think that was my socket set. Now let me get the wires bent into place there, and we're going to disconnect this and reconnect it. And we have 13.3 volts, which according to the manufacturer shows a fully charged battery. Okay, next we're going to come over here and we're going to turn on the inverter will start drawing power off the battery right away. So what I'm going to do is plug the freezer in to the kilowatt meter first. All right, make sure we got a good contact there. And then I'm going to move the camera over a little bit on an angle here so I can get a better view of things. And I'll just have to go back and forth on it. All right, so to start with, I'm going to turn on the inverter and watch the numbers come up, and then we'll go through and I'll check the volts, amps, and watts on this, and the kilowatt hours, make sure that they're at 0. So there's no shenanigans going on, right? So you'll also see on the meter here what the total voltage of our battery is, and this is guesstimated. And then when we do the amp draw, you'll see what the amp draw is on here. Now, I did have the freezer door open for a while, and I did promise I would show you inside of that. So let's look inside, and you can see it is just a freezer. There is nothing else, no refrigerator part of this. This is just freezer. So I did have the door open to make sure that it's ready for the compressor to kick on as soon as we plug this in or turn this on. And then as soon as we get numbers on there, I'm going to start the stopwatch over there so that we know that we started it on time, and we'll see what we're going to get out of it, right? All right, so here we go. Power on. And we have 120 volts coming in. Our amp draw, 1.07 on the amps. For the watts right now, we are pulling 128 watts, then 129 watts. And that's what I did test this thing at when I first got it. So I know that is correct. That's what this freezer does pull. So you can write that down on your paper. 128 to 130, well, 131, 132. Yeah, 130. Just let's call it 130, right in the middle of it all. So write down on your piece of paper, 130 watts running at 120 volts. So you can divide 120 into 130, and that tells you what kind of amperage we're drawing. All right, so we're running at 60 hertz, and then on the watt hours, we're at 0 because we haven't done anything yet. So let's go back to watts on this, and we'll keep an eye on the watts. Now, I'm not going to be running the video for this because I have a feeling this is going to be very many hours. But what I will do is cut the video, and then when I come back to do a check on it, I'll start another video, and then I will patch them all together with my editing software when I'm ready to post the video online. All right, so now we've started with, and we've added a few seconds or minutes. We can always go back and look at the video from when I started that and add that time to the stopwatch. And I'm going to start the stopwatch right now. There we go. There we go. So the stopwatch is running minus the minute or two that it took for me to get to turning the stopwatch on. And we'll keep track of that later. I also have my electric coffee maker here, and after the freezer and the air conditioner test, we may even just plug that coffee maker in, and I won't brew coffee, but I will put some fresh water in there and just brew some hot water, and maybe use that for a cup of soup or something. But we'll see if it will handle the power that that thing draws, and see what kind of drawdown it has. All right, so just before I shut all of this off, let's go back, take a closer look at the gauge here, and it is saying 13.2 volts, no amp draw, because we don't have anything coming into this thing. So the charge side is disconnected, only the battery side is connected to the battery. All right. So that's done. I'll come back over here, and let me set this down and tilt it. And now we're drawing 78, 79, 77. So it's getting down to temperature now, and it will shut off and go to 0 for a little while, and then it'll come back on as it needs to keep everything cold in there. And I'm not going to stay away from this thing all day long and through the whole video. I will be reaching in there and getting stuff out, because I have little blocks of ice in there I use for my cold drinks during these hot days. So I'll be using the freezer during the testing here. So just like you would in your house, you would not just leave the freezer closed for the duration. You'd still want to get stuff out of there and put stuff in there. So that's the way it's going to be done. A true to life test, right? All right, everybody. So I'm going to cut this video off right now, and we'll come back to it a little bit later. Since I'm not really planning on going anywhere, I'm just going to pause this video and maybe just add on to it in a few hours we'll see where we're at. All right. It is now, let me check the time. It is now 2 p.m., 2:01 p.m. to be exact. So write that down on your paper, everybody. And I'm going to pause right now. Well, good morning, everybody. And here we are, stone dead. No numbers on that at all, as you can see. And the inverter shut off, even though the switch is still on. And the kilowatt is shut off. And that might be a problem because what happens with the kilowatt when it loses power is I lost all of the information that was on there. So over here though, I shut this off and had a problem there too. The problem was that of course I couldn't step all night. I had to close my eyes for a little bit. The last time I got up and checked it, it was at 13:41. So at 13 hours and 41 minutes, the system was still running. So somewhere between 13:41 and 16:52 is when it shut off. So I can actually say from that you're going to get, no doubt, 14 hours of running of a freezer on that battery. Now, here's the interesting part. That battery is stone dead. I mean, stone dead. It took everything it had out of it, and you see it's not registering anything on the meter here. So what I'm going to do here is I'm going to disconnect everything. I'm going to take the wires off that go to the inverter, and I'm going to put my charger back on, and we're going to start charging this thing back up again and see where it goes from there. So stand by, I'll be back. Well, I'm back, everybody. I've got the inverter disconnected and everything, and we are in charging again. So I have it set at 22.6 or so volts going in on the machine at 4.7 amps. And let's see if I can get in a little closer here and get a look at this. We're already at 12.2 with 7 amps charging. So the battery will take a charge up, and I'll be back to do the final closeout on this video and give you some of my insights on it, and also we'll go through the manual and the parts and stuff that came with this battery. So stand by, everybody. Hello, everybody, I'm back. And it's been a couple hours since I got up and we looked at everything here and the timer of how long it ran. And we'll go over all of that in a second here, now that I'm fully awake. Even though I'm tired for having gotten up 2 or 3 times during the night to check this test out. And let's get with it. Alright, so WattCycle 12 volt 100 amp hour battery in the group 24 size. What do I think about it? Well, I think it's an excellent battery. It definitely has proven itself in this experiment. Alright, so what do you get with this battery in the package? You'll get 4 of the M8 bolts. That's 8 millimeter. That's why they say M8. You get 2 caps to cover the bolts at the top after you make your connections. to protect accidental short circuiting by dropping a tool or a wire or something like that on them. I'm sorry, I just had one of those little irritating insects just landed on my leg. All right, so this is one thing I do like about this battery. I've noticed in other batteries it doesn't. They don't do this. They give you 4 bolts. Everybody usually gives you 4 bolts, and that's a good thing. Except, what do you need 4 bolts for when there's only 2 poles, right? Well, this company knows why. These bolts are actually longer than those bolts that are in the battery. And why is that? Well, you can use the short bolts if you only have one set of wires going to the terminals. But let's say you want 2 or 3 wires, battery cable wires going to the terminals. Well, you need a longer bolt. So they provide you with those. And these are stainless steel, so you don't have to worry about them rusting. The other nice thing is, this is LiFePo4, so you don't have to worry about corrosion. All right? So, next, the manual. Now, right above my thumb here, look at all of the different size batteries that this company makes. Now, this bottom one here, 12 volt, 400 amp hour. Think about that. That is an excellent, strong battery. Now, if you take 4 of those and you hook them up in series, you're going to have a 48 volt battery at 400 amp hours. That's a lot of amp hours. That's like, somebody do the math for me, something like 19,000 plus watt hours. That means you can run 19,000 plus watts for 1 hour. 19,000 watts. Think about that. That's a lot of watts. I mean, that is really a lot of watts. So anyway, that would be a great one for doing a small 48 volt system and starting only with 4 batteries. Of course, 4 batteries would be nice, but I would say at that size, go with 8 batteries. You'd be running stuff you never thought about running. All right, 12 volt, 50 amp hour. That's more for a small trolling motor for fishing and things like that. I wouldn't go any lower than the 12 volt, 100 amp hour for any type of off-grid use or camping use or anything like that, unless you're just going to do an overnighter and all you want to do is run some lights, a charger for your cell phone and computer, things like that. Go to 50 amp hour. All right, but everything else here, great selection. So let's take a look inside the manual quickly and see what we have here. They start off with all of the cautionaries, things that you have to worry about, things that make sense, like do not short circuit, yeah, do not crush, yeah, do not disassemble. All right, now a lot of guys do that, they do disassemble them. That's because they want to show you that they know a lot about electronics, so they can open it up and they can name all the components. You as a consumer really don't need that, like I said. All right, so here's your product overview. And there's your table of contents. Here's your discharge curve and charge curve. Okay, the charge is the blue, the discharge is the yellow. So as you can see, you're going to run from 13 something, I'd say 13.3, 13.5, and then it drops down a little bit, and then it carries out at 12.8, goes down to 12.7, 12.6, 12.5, and that stuff, and gets all the way over to like, I'd say that's probably 12.4, about there, and then it drops off quickly. So at 12.4, that's when this battery last night decided to shut down. But you got to remember that the inverter I was using is an old inverter, and a fan runs constantly in that thing, not on and off as it needs it. And that uses a lot energy. So the idle consumption on that inverter, you have to figure that into the equation also. So I would say the battery definitely passed that test. So here are all your specs that you're looking at, and here's the line that we would be looking at. This this battery does come with high temperature charging protection, high pressure temperature low or discharge protection, low temperature protection if you're charging and the temperature drops below 32 degrees Fahrenheit. The battery will quit charging so you don't damage it. And that's a good thing. So this is something I want to stop right here and cover with you guys who are thinking about getting LiFePo4 and you live in a fairly cold or very cold climate. All right. So they're talking about 32 degrees for the cutoff on it. Now, if you have your batteries all inside of an enclosed, insulated room, and you don't have to worry about off-gassing of these, so you don't have to worry about dying from the fumes that the battery puts off while it's charging. So you can put it in a nice insulated room, or actually right inside of your cabin, or inside of your motorhome, or inside of your van, wherever. Don't worry about any gases coming off of it that are going to cause you any human discomfort. So yeah, you can keep them in a room to keep them warm. If not, you got multiple batteries, pack them all together and insulate them with some styrofoam sheet or something like that to keep that heat in. Normally you can keep them above 32 degrees. Now where I live, if we have temperatures down below 32 degrees, it usually is overnight only, not all day long. As soon as the sun comes up out here, even if we had snow overnight, the sun comes up an hour later, the snow is all gone, and it starts warming up again, and the temperatures are in the 60s. So here I don't have any worry about the cold temperature protection. All right, so remember that. So next page, the battery parameters. Now this is all information that you normally don't care about, but remember, this is IP67 waterproof grade. So you can use this thing around boats and stuff like that where there's a possibility that a little water will get in. I also recommend that for RVs where you have an outside battery container for the battery. So if the rain's really heavy or they're splashing puddles on the road and things like that, your battery is protected. All right. Your self-discharge rate, as all, less than 3% a month. I've seen that on every single one of the LiFePos I've looked at. So that's standard. Everything else is basically standard information. But these numbers up here, these numbers right here, these are the things that you want to know. Right down to, let's see, right down to about here. You want to know that if you're going to use a charge controller like a Midnight Classic that is not set up and prepared for LiFePo batteries. You have to go in and set all your parameters by hand to meet the standards of LiFePo4. You're not going to be able to just hook it up and go. There are changes in the parameters, okay? And that's because, like, things, standard voltage, 14.6 plus or minus 0.2. That's fine. But on a Classic, you could get 14.8, 14.9. I've seen 15 go through it. So you need to get in there and set your limitations on that. Now it does ship between 12.8 and 13.5, and that, like I said, that's why we had to charge it in between. Now it's running on the charger right now, and I see the last light on the controller over there is flashing. That means it's almost fully charged, and when that goes solid, then I'm fully charged. All right. Let's see what else we have here. Installation environment, preparation, inspection, cable sizes, very important. What size cable in gauge do you need to run the total amps that you're running? Okay, now that's not saying, well, that's 100 amp, so I better get something that's like 2 gauge for it for 100 amps. If you're not going to be running 100 amps out of there, if you're just going to use it for a camping battery and you're just going to be running maybe 20 amps tops for a charger and some lights and things like that, don't worry about going up to a higher gauge wire like that. You could probably get away with 10 gauge or 8 gauge or whatever. So stay in that frame of mind. If you're going to be using it off grid to power your cabin, then yes, you want to go up. As a matter of fact, I recommend, just for the heck of it, because you may decide to add more batteries down the line. If you're going to spend the money, spend it once. Go to 4 gauge or 4-aught gauge, because 1-aught gauge is going to give you 150 amps. 4-aught gauge is going to give you 230 amps. You're very seldom ever going to see you pulling 230 amps into your cabin, but you'll have the wire to handle it anyway, and you'll have no voltage drop loss between the battery and your inverter. All right, or if you have multiple batteries, you'll have no voltage loss between batteries. So I recommend just go ahead, go with the largest cable you can get the first time, and you'll be safe for a long time. All right, so gives you your different wiring diagrams for different connections of the batteries. You want your series or parallel connection, series or parallel, or if you want series parallel, remember you can go 4S, 4P. 4S means 4 in series or 4 in parallel. So you can go 4 groups in series and put those all in parallel, and you still have 48 volts, but your amp hours will add together. If you go with a 12 volt, you start with a parallel connection of 12 volts and you hook those up in series. You're going to add your voltage in the series, so you don't want to do that. So you want to stay with, if you want 12 volts, you got to stay with everything in parallel, but you could still do 16 batteries. And that's just because of the limitation of the BMS, which stands for Battery Management System, and that's what we're talking about here, BMS function. Okay, so here's all the information on your BMS function. Very nice manual, very easy to understand, even for laymen. Let me get to the next page here. Felt like I was going 2 pages. Applications, what will you use it for? What should I do if the battery is at 0 voltage? Okay, that's a very simple thing. All you have to do is give it a little juice to start with, because a lot of the battery chargers will not charge from 0. You got to have some voltage inside. I don't have to worry about that when I'm using this type of charger, because this is a power supply and it's putting out electricity no matter what, and it's going through a charge controller, a solar charge controller. In other words, that charger or power supply is acting like solar panels. Okay, so it's doing the job of the solar panels, putting the power into the controller. Then it comes out of the controller at a controlled voltage to charge the battery. And this battery will be fully charged here anytime now. I'm charging it at a lower amperage rate, so it's probably going to take 5 hours total to make sure I got a fully charged battery. But once I'm done with that, I've got other things to move on to. But I will be doing a follow-up on this. There's your warranty, after-sale service, and all that. I'll be doing a follow-up on this battery because, like I said, I like this battery. I really like this battery. And that being said, I'm going to probably use this in my van. Well, not probably, definitely going to be used in my van. And once I get that set up, I'm going to show you the changeover. I have 2 sealed lead acid batteries in there now. And the two of those I'm carrying around probably the weight of another human being all the time, which is a gas guzzler. And I'll take that out of there and I'll put this 24-pound battery in there, and that'll be a much lighter load to carry with more power. And it'll be one battery, not two. Be easier to secure. Nice idea. And we'll be showing you that in the future here. So that's all I have on the WattCycle for right now. Remember, recapping, one battery without any charge going into it, just running from a full charged battery, will run a freezer this size. Now, one other thing, this freezer uses exactly the same amount of power as my full-size refrigerator. Okay, so I can run my full-size refrigerator on here. Don't think just because it's a small freezer that it's more energy efficient than the big refrigerator. They all run on the same compressor. It's just what the difference is, what the type of gas they use for the coolant. Okay, so one for freezer is a different coolant number than the one for refrigeration. And that's what makes the difference. But the compressors are exactly the same. They use the same amount of power. So you can run either this size freezer or a full-size refrigerator. I estimate, to be sure, absolutely be sure, you've got at least 13 and a half hours, because that's the last time I checked it on this stopwatch. I checked it at 13 and a half hours and it was still running strong. Now, somewhere between 13 and a half and 16:52, it shut down and I was asleep, so I missed it. But that's a long time to run on just that one little 12-volt battery. You wouldn't think that you could do something like that, but you can. And I'm also going to try running my window air conditioner on it and see how long that lasts. But got to wait for a full charge before I do that, and that'll be another video. In the meantime, look in the description below, get my my link for my past video that I did a few days ago, and enter into the giveaway contest to win a battery like this. I still haven't heard back. The rep doesn't usually contact me on Sundays. I'll hear from her tomorrow on Monday, and then I'll put out in my next video, I'll put out the information. I want to make sure that they're offering me 4 different size batteries to give away and not just one of the 4 different size batteries. So I'll be looking forward to that. You be looking forward to that, and I'll see you on the next one. And this is G Bear signing off.